I need to point out where we are in the book. We're doing sections 4.9 and part of 5.4 today. 4.9 and 5.4 do exactly the same thing for a good part of section 5.4. It's just that they're calling what we're doing anti-differentiation in 4.9, and in 5.4 they're calling it indefinite integration. It's the same thing. Why redo the section twice? It's just using different notation. The notation in 5.4 is the standard notation that everybody eventually uses. So why use crude notation and then turn around and use easier to use notation? We're going to go great into 5.4. But if you read 4.9, it'll be helpful to you because, again, the concepts are there. Now we're going to temporarily skip 5.1 through 5.3 and do them probably next week. I mean, we are going to do them. Don't think we're not going to do them. They're important. But I think it'll be next week when we get to those. 5.1 and 5.3 deal with the topic of definite integrals. A definite integral looks like an indefinite integral, only you've got these numbers here. Turns out that a definite integral means something very different from an indefinite integral. And that's why we're going to kind of separate our discussion. Since we've done differentiation, we're going to do anti-differentiation or indefinite integrals. Again, this indefinite integral means the most general antiderivative. Makes sense to do this first because we've differentiated. Now we're going to go backwards and anti-differentiated. And then later we'll do this definite integration, which means something very, very, very different. And then we'll see how these two are connected by something called fundamental theorem of calculus. So this is kind of a roadmap where we are for the rest of the semester.